Hi guys, today we are going to see this BCD to 7 segment display. This is one sort of code conversion by using the Logisim software. And in this, hi guys, good evening. And in this video, I'm going to tell how to install Logisim, and we are going to do experiment called BCD to 7 segment display, and use this link for downloading your Logisim. It's a free software, so you can download here using this web link. And why I am not using the selfie spices? There is no LED display here. You can visualize all those things only in the form of waveforms. That is why we are going ahead with Logisim for this particular experiment. Download. You will be having an exe file, and you can install it. After installation, you can open your Logisim. It will be like this. Your menu will be like this, and we are going to implement this particular experiment called BCD to 7 segment display. Okay, so 7 segment display, you have 7 segments A, B, C, D, E, F, G, and of which you have common anode and common cathode connections. But here in Logisim, it works on either way. So as of now, we just have it in our mind that whichever we have derived using K-map, the simplified expression, A, B, C, D, E, F, G, those seven expressions. So those 7 functions we are going to implement by using this Logisim. Okay. So for the first expression name A, you need an XNOR and an and a direct thing. Before that, the inputs are nothing but A, B, C, D are the 4 inputs, because we are going to convert BCD to 7 segment. So BCD input is A, B, C, D. So we need 4 inputs, namely A, B, C, D. Okay. So see here, you have an add pin. Okay, control +4. That is your shortcut menu. So you can add and place it here. This is A, okay, and this is B, and this is C. It's a quite complex circuit. So I ask you to pay attention while doing the circuit. Okay. So this is A, B, C, D, and see in the expressions. In the expression, we have A bar, B bar, C bar, D bar, and all. So what we need to do for each input, we need to connect a NOT gate. We need to connect a NOT gate. Let me connect a NOT gate here. I'm sorry. Uh, Let me connect a NOT gate here. So let me take and place a NOT gate. So in front of each inputs, let me place this NOT gate 1, 2, 3, and 4. Okay. So after that, what is your expression? For each expression, you need your OR gate. Right. So for all the expressions, you need an OR gate. So totally, we need 7 OR gates. So let me place the OR gate first. In the gate section, you have an OR gate. Even here, you have an OR gate. So place it here 1 and 2, 3, 4, 5, 6, and then you go to 7. Okay. So let me go ahead with the first expression A. A is nothing but we need one XNOR, one AND, direct A. Okay. So one XNOR, one XNOR, one AND, one AND, and a direct A. Okay. And a direct A. Because I feel it was it is congested here, so I just remove that. Okay, so you can directly connect it. Click on your mouse, and this is A. Okay, this is A. So QA connecting. Okay, and the CD. Okay, let me connect it here. Keep in mind this put together combination is A bar and B bar, C bar, and D bar. Okay. So the next thing is C and D. Okay. C and D. Okay. So CD has to come here. So this is C. Whereas this is D. Okay. C and D. And then B and D. This is D provided this is D. Okay. D XNOR D. So that is why I have given to the XNOR gate. I took XNOR. Sorry, I took an instead I took an XNOR. Okay. So now it's an XNOR gate. Okay. So this input meaning this output has to go here, and this also has to go. So the first A combination is over for us now. Okay, A is over. We will go ahead with B. Again, we need one XNOR and B bar. Okay, so XNOR and B bar. So B bar has to come from the NOT gate. So let me take here directly B bar. Okay, B bar that has to be given to the OR gate, and the XNOR output has to go here, and then the input will be C and D. So this is D, and this is C. Okay, C and D. So D is also over, and C is C bar. So C bar is this. Directly we can get C bar is this, and D and D. So D is this. D, D is this. Okay, and then D is nothing but we need four AND gates. C B bar D bar, B bar C, B C bar D, C D bar. Okay, we need four AND gates. So let me place AND gates first. Okay, so 1, 2, 3, and then 4. Okay. So the first AND gate is B bar and D bar. So D bar is this, whereas B bar is this. After the NOT gate, we will be using the B bar. So first is done, and B bar C. So I can take from here itself. Okay, B bar C is here. So C, and then B C bar D. So B is this, B and C bar, and then this is my D. Okay, this is my D. C D bar. C is this. I'll go from here. C and D bar. So D bar is this D1. So this is also done. 4 AND gate is done, and from the output you need to connect it to the OR gate because all the AND gate combination is here. Okay, so this is also done. Okay, this is also done. So now A is done, B is done, C is done, D is also done. And then E. E is B bar D. See, already B bar D is in the first AND gate, so no need to implement this AND gate again. I can take a line from this first AND gate of D segment. Okay, and C D bar is also it is already there as a fourth component of your D segment. So for the E, I can directly take from this AND gate to the OR gate. So the first AND gate and the last AND gate. The first AND gate is this. For this combination, first AND gate is this. The last AND gate is this. So E is also done. Let me go ahead with F. So for the F, nowhere this combination is available, right? So F we need to implement. So we need 3 AND gates. Okay, we need 3 AND gates. Let me place the AND gates first. So to have this, okay, we need 4 AND gates, 3 AND gates. Yeah. So let me place it here to avoid this space congestion. No? Let me place it here. Even I can take it here. Okay. It looks somewhat odd, but this is particular software is like that. So we need 4 gates, and gates, 3 and gates. I'm sorry, 3 and gates, and 1 direct A. Okay, 1 direct A. So C bar, D bar, C first, D. Let me implement these things. Okay, C bar, D bar. So D bar is this. C bar is this. Just I'm taking C bar first. Okay, C bar, and then this is D bar. C bar D bar. Yeah, and then B D bar is here. B B D bar. I hope I'm right. Yes, B D bar. Mm, B C bar. So already I have taken this E. So from here itself I can take again B, and then C bar. C bar is okay. And along with this, I have one more component named A. So A is this. Till now nowhere A is used except for F and G we are not using A. No, A for the first segment A we have used. Right. Other than that, we have only for F and G. Okay. So for F and G, so from here, this is my A. I take it here, do this. Yeah. So now this has to be connected to this socket. Again, this, and again this, this. Oh, okay. Again this one. Okay. So now the segment F is also done. So for the G, see the C bar, D bar is available here in the D segment. That is this fourth gate. And then we need one XOR and the direct gate. One XOR. So XOR I'll place it here, or I'll place it here. Better. Okay. I'll place it here. And one OR again, because you need to place the last segment, right? Done. So XOR input is B and C. So B is here, whereas C is here. This is done. One XOR is done, and another one is C D bar, that is in the fourth AND gate of D segment. So this is the fourth AND gate. So let me take it here, come back, connect it here, connect it here. Okay, and finally you have a A. A is here. Okay, so now all the 7 segment we have connected to the logic gates. Okay, all the 7 segment you have connected to the logic gate. Nowhere your A bar is used. Nowhere your A bar is used. So I think I can delete this. Okay, right. Now let me go ahead with this 7 segment display. It is 8 here. Input output. Yeah, 7 segment display. Okay, place your 7 segment display here. Okay. Before that, let me name these inputs. Okay. Okay. So this is A. So A, B. See, click on it. Left side. In the left side, you have a label. Connect with C. And this is your input again. This is your D input. Okay.
This is how we'll be implementing it in the platform. Okay guys, we have connected the circuit and we have named the A, B, C, D also, and let us connect to the each segments A, B, C, D, E, F, all the segments to the 7 segment display. Okay. So let us connect A. See how, well, listen carefully. So from here, actually this is A. Okay, this is A. You have 7 segment display. After the 7 segment, you have a point, decimal point also. For example, here we have taken only one display. If we are going to take 2 displays, namely if you want to display a 2-digit number, namely 8.8 at that time and all, you need a decimal point. So we have 8 lines to the 7 segment display. Okay, 8 lines or 8 output pins or 8 pins to the 7 segment display. So each of this segment will be connected to the corresponding segments. Okay, corresponding segments. So that is what I want to say you. This is 8 segments A, B, C, D, E, F and G. And this one is nothing but your display. This one is just not your display. This is your decimal point. The decimal point. Okay. So if I want to display more than a digit, at that time and all, this decimal point will be useful. Okay. So now let us connect here. So this is A. Okay. This is A. And then let me label here. This is small a. Okay. And then label, go here. This segment is B. Okay. This segment is B. And then, so for C, from here connected, come to the bottom. Okay. Leave one line, one pin, then connect it to the next pin because that pin is meant for your decimal point. We are going to display only single digit, right? So that is one. And then this is C. So let me name it and keep. Then it won't be confused. Okay, then B. Then this is C. Then D. D. This is D. And this is E. The first bottom pin from left hand side. So let me name. Okay. So this is D, whereas this is E. Okay. And then again disable this text. You need to go ahead with your this. Then F.
Here, in the top of the LED display, two things is left, right? So the second pin is F, and then one thing is left. This is it. Okay. So again, let me name this F, and then sorry, this is F. This is G. Okay. So that's how this is done. We will check with inputs. So already it is I have connected. I have named each and every individual gates. Okay, like what is the output of each gate. Now let us check whether this is behaving properly. Okay, so first 0, 0, 0, 0, 1. See 0, 0, 0, 1, 1. So first let me start with all 0 and then 1, and then I'll go ahead with 1, 0, 2, 1, 1, 3, and then 1, 0, 0, 2, 1, 0, 1, 5, 1, 1, 0, 6, 1, 1, 1, 7, and 1, 0, 0 is 8, 1, 0, 0 is 8, and then 1, 0, 0, 1 is 9. Earlier I have given hexadecimal input, that is why an error was there. Okay. I hope you understand this. With this I stop today. Thank you. Simulate this and check your Logisim.